start off by looking at 2.2 part 2. And what we're going to look at is basically graphing something on the screen and trying to figure out where two graphs cross or intersect. I think we've done something like that before. So probably not really a ton of stuff new, but let's just give it a shot. So we're going to look at an example where we're going to be dealing with a company, and the company is going to have two kinds of costs. One cost is going to be what we call fixed cost, and the other one is going to be variable. So our particular company is going to be making, I think they make shoes or something. Oh, shirts. Okay, they make shirts. So an example of a fixed cost might be how much money the company has to pay to rent the building they use to make the shirts. It doesn't matter how many shirts they make. They pay the rent for the building. They can do whatever they want in the building. Okay, so they don't have to pay rent based on how many shirts they make. That's a fixed cost. But the variable cost is the number of shirts that they make. Because the more shirts that they make, maybe the more ink they have to use. So every shirt costs a little bit for the ink. Every shirt costs a little bit because you have to buy a shirt that's like a blank shirt to print on. All right, so every shirt costs them money. So this company has a fixed cost of $200,000, and it costs them $1.50 for every shirt that they make. And that's variable, because that changes depending on how many shirts they make. But they sell each shirt that they make for $4. Now, as I go through this, there's three different words that I'm going to be using to describe things: cost, revenue, and profit. So cost is how much money the company has to spend, right? It's how much money they have to pay to afford to do what they do. Two types of costs, fixed and variable. Revenue is just how much money the company takes in. Okay? Revenue is just what they take in. Profit would be the difference between the two. So if you take your costs, or if you take your revenue, which is how much money you took in, and subtract your cost, which is how much money you spent out, what you're left with is a number that represents profit if it's positive. If you take your revenue and subtract your cost and you get a negative, then that means you spent more money making whatever it is you made, and that's not good. Okay, so you want profit to be positive. So let's find two different graphs. One graph is going to represent the cost. The other graph is going to represent revenue. And that's it for example one. Okay, we're just going to write down two equations and graph them. We're not going to solve anything yet. Just find a couple graphs. Let's start with our costs. Okay, two types of costs. First of all, how much are the fixed costs for this company? These are the costs that don't change. Yeah, Lauren?
Just the $200,000.
That's the $200,000. So there's fixed costs, plus we have a variable cost. Now, does it tell us, let's let X represent the number of shirts that we sell. How would you represent the cost to make the shirt? I mean, I know how much it costs to make one shirt, but how would you represent it if you made X shirts? Yep.
You would plus 1.5x.
Yeah, we'd have to put a plus 1.5x. And there's a formula, kind of like y equals mx plus b, with a slope and a y-intercept for your costs. and revenue. Okay, so revenue is basically what the company takes in for every shirt they sell. So what do they sell each shirt for? 4, and we're going to be selling how many of them? X. I'm not saying that all the money they take in is profit. I'm just saying that's the revenue. 4x. Okay. And they want us to graph. So Quinn, is that, if I graph that, is the standard window going to be good? No. Because what's my y-intercept on my cost? 200,000. So when we graph this, we want the costs to be at least 200,000, but then they're going to go up from there. So I would probably set the y-max maybe at 300,000. Okay, we're going to have to set that pretty high. Okay, 1.5x plus 200,000, 4x. So x is the number of shirts we sell. What would be the smallest number of shirts you could sell? 0. Can't go lower than that. The most number of shirts you could sell? Well, we don't know. Let's say maybe we sell 10,000 shirts. Y min, Y represents 2 things in this case. It could represent the cost if you look at the first graph. It could represent the revenue if you look at the second graph. But either way, you can't go below 0, right? If you sold 0 shirts, 4 times 0 would give you $0 in revenue. So there's no reason to go negative for revenue or cost. And the Y max, well, we have to go above 200,000 because that's where the line starts. So let's try 300,000. So there's our cost. There's our revenue, but it's said to find a complete graph. I don't think that's a complete graph. What do you think I'm looking for here? Yep. Go ahead.
When the revenue passes the fixed cost.
Yeah, when the revenue passes the cost. So which one of those do I need to adjust? The X min, X max, Y min, or Y max? Yeah, X max. So maybe instead of 10,000 shirts, let's do like, let's do 100,000. So let's say we sold 10 times as much. Now we can see the costs. We can see the revenue. I think the X max is good now, but what do I probably need to just make a little higher now? Yep.
The Y max.
I would make the Y max a little higher. So let's go, instead of 300,000, let's go 400,000. I think that'll be good. So there's your cost. There's your revenue. Yeah, that's good. And that's it. So for that one, you'd want to just write down the window. And here is the window that we used. Yeah, not the only window you could use, but that's a pretty good one where you can clearly see where they cross. Now, this point has a special name. If you own a company, when your cost and your revenue finally match up. Does anybody know what that point is called? Yeah?
I mean, it's breaking even.
Yeah, it's where you break even. And that's called the break-even point. It's where you've now made back all the money you had to invest to start your company or pay your costs. And anything from this point forward is now profit. So a break-even point is when the cost and the revenue are the same. So if you look at a graph, the cost and revenue are the same where the 2 lines do what? Yeah? Where they intersect. So for a graph of cost and revenue, this point is where they intersect. So now what we're going to do is use the equations we just put in the calculator, and we're going to find out how many shirts do we have to sell to break even. And first, I'll show you how to do it algebraically, which in this case, it's probably faster to just use algebra, because by the time you type in your first equation, your second equation, do second calc, intersect, and all the stuff you got to do, I probably could just solve it quicker with algebra, because these equations aren't too complicated. All right. So let's remember what the break-even point means. Cost and revenue are the same, or basically cost and revenue are equal. So algebraically, that means this. Cost equals revenue. Just substitute in what we had for cost and what we had for revenue from the previous page. What was our formula for cost in terms of the number of shirts we sell? Andy?
1.5x plus 200,000.
1.5x plus 200,000. And what was our formula for revenue? Yeah, Max? 4x. And now just solve that equation for x. So minus 1.5 from each side. And Sam, if I minus 1.5 from 4, what will that give me?
Oh, shoot. I'm being bad at math right now. I'm lost right now.
3.5?
If you minus 0.5 from 4, you get 3.5.
Oh, sorry. 2.5.
2.5. All right, so 2.5x. And Lucas, how would I get x by itself there?
Divide.
Yep, divide by 2.5. And if you do that out, I think you get 80,000. You can double check me on that.
Yeah, I think it's 80,000.
Okay, so that's 80,000 shirts. There we go. So 80,000 shirts. So to solve it algebraically, really not that bad. 2 steps. Graphically. So you might want to do it graphically if you can't figure out how to do it algebraically. Or if it's a problem that you just want to double check your answer, you can do it both ways. Okay, anybody remember how I calculate an intercept? Like what do I have to press? Matt?
You press second and trace, and then you go to 5.
5, yep. Okay. And now what?
So you wanna, I think it's fine if you just press enter where it is now.
Yep.
And then you press enter again.
So the second time?
For the guess, you wanna put it roughly around where you think it should be.
Yeah, you can move it a little closer. That's good enough.
And then you press enter again, it'll give you the answer.
Yep. So when we do that, you can see we get the same thing. We get 80,000 shirts. Now, looking at that graph, if I sell 80,000 shirts, how much is it going to cost me to make 80,000 shirts? Yep.
320,000.
Well, it will cost me $320,000 to make 80 shirts. How much revenue will I take in if I make 80,000 shirts? Yep.
Well, 320,000.
320,000. I will spend 320,000 to make the shirts. I will get 320,000 in revenue. Therefore, I'm now at 0. If I continue to make shirts, now I'll make money. Yes.
Is the break-even point always the x value?
Yeah, the break-even point is the number of things you would have to sell to break even. That's always the x value. And that was all that was left in section 3.2. So any questions on that? Or 2. No, not 3.2, 2.2. Question? No? All right, 2.3. So in the last problem we just did, we just solved a linear equation algebraically. So we'll practice solving a few more equations like that. And then we'll also talk about quadratics, which are a little bit different to solve, but there's a couple different ways we can do it.
Mike, can you go down?
Yeah. So first of all, remember, back to Algebra 1, what is an equation? So an equation is when you take two expressions, usually one of them has a letter, and one of them doesn't, like in the simplest case, like 3x, that's an expression. 15, that's an expression. And you put an equal sign between the two of them. That's an equation. At least a relatively simple equation. Now, this particular equation uses x for the variable. We can use many different letters. But if my equation uses x, then what I could say is I have an equation in x. If I used L as my variable, I could say that I have an equation in L. So if you see directions on a problem that say, write an equation in x, all that they're asking you to do is write an equation and use x as the letter. So when we want to solve an equation, that just means we're trying to find a value or values. Sometimes there's more than one, especially with quadratics. But find the values of x that make it true. So if I just go back up to this one for a second, 3 times something gives me 15. In this case, it would be 5. 3 times 5 equals 15. And 5 is the only answer to this problem. Okay, there is no other answer. Here's another example of an equation you could solve. One extra step compared to the last problem, but still not too bad. If you were to solve this equation, what would you get for x? 4. You can get x equals 4. Now, let's look at something like this. 3x plus 4 equals 2 times x plus 2 plus x. If you wanted to solve that one, first thing you'd have to do is distribute what's on the right and combine like terms. There's nothing you have to do on the left. But what do you get if you do the distributive property on the right-hand side? Laura?
2x plus 4.
You get 2x plus 4 plus x. So it would end up being 3x plus 4 on the right. Well, that's also what you have on the left. If you go to solve an equation and something like that happens, where you end up with exactly the same thing on the left and on the right, that is called an identity. That's an equation. Actually, here's another. Is this the same one? No, not quite, but it's similar. An identity is an equation that is true for every single number. It's not like this one where the only answer is 4. In this one, the answer is any number you can think of. 2, 6, 12, -8. It doesn't matter. So if we started to solve this one, you'd end up with 3x plus 3 minus 1 And then when you combine your like terms, 3 minus 1 gives you 2. Positive 2. And if you subtract 3x from each side, put all your x's on one side, you end up with 2 equals 2. Well, that's true. Yes, 2 equals 2. So when you end up with the same thing on both sides, that's called an identity. So you can't plug in a number for x here that wouldn't work. Everything works. Any question on that? So that's called an identity. I didn't mention it earlier, but this kind of equation is called conditional. There's a condition that makes that one work. The condition is you have to let x equal 4. So a conditional equation is an equation that is true under the right condition. You have to plug in the right number. All right, so yeah, conditional equation, true for certain values. This one would be true if you let x equal 5. Yeah. All right, so if you are asked to check if a number is a solution, okay, like if I say to you, tell me if the number 2 is a solution to this equation. You take the number that I give you, you plug it in, and you see if it works. You'll know if it works because you're going to end up with something that's true. If you plug a number in and you end up with something that's false, it means that your answer doesn't work or you checked it wrong. So like if I just go back to this one. If I said, tell me if 4 is a solution to this. Well, if you check it, plug 4 in for x. 3 times 4 is 12. 12 equals 15. No, 12 does not equal 15. Those are different numbers. So that would mean 4 doesn't work. If you plug in 5, you get 3 times 5 is 15. 15 equals 15. Yeah, that's true. 15 equals 15. All right, so I'm going to give you an equation that would be a little harder to solve, but that's not the point. You don't have to solve it. All you have to do is check if the number that I give you is a solution. So the equation is x cubed minus x plus 6. And the number that I want to check if it works is negative 2. Yes?
Do you want the no if it is or not?
Well, tell me how you would do it. What do you have to do with this negative 2 to check if it's a solution?
So what you would have to do first is plug in negative 2 for both of the x's.
Yep. Plug in negative 2. And anytime I plug in a number, I always put it in parentheses, especially if it's raised to a power, because this negative is part of what's being cubed. Sometimes that matters, sometimes it doesn't. We'll see what happens here. So plug in negative 2 for both of the x's. I'm going to put a question mark there because I don't know if it equals 0. That's the hope. And when I do this out, Alexis, what's negative 2 cubed? Negative 8. Right, so negative 2 times negative 2 times negative 2, negative 8. And then, Caleb, minus 2. What happens there?
Yeah, but make it, you have to add 2.
So we're going to add 2. All right. Keep going. Alex, what's negative 8 plus 2? So negative 6. And now we can see negative 6 plus 6 is 0. So I get 0 equals 0. So Eileen, is negative 2 a solution? Yeah. Is it the only solution? Well, I don't know. That's a different question. But I know negative 2 is an answer that works. Okay. Any questions on how to verify a number is a solution? So this is generally what a linear equation looks like, or it can be rewritten to look like this. You usually have a number times x plus a constant, and you could get it equal to 0 if you wanted. All right, so if I go back and just look at this one for a second, you might say, well, that doesn't fit the pattern you just said. No, but it could be rewritten to fit the pattern I just said. 3x minus 15 equals 0. Would you do that to solve it? No, probably not. But the point is, if you can write it so it's a number times x, plus or minus just a number, equal to 0, then that fits the pattern of what we call linear. Now the b can be anything you want. Could be a positive number, could be a negative number, could be a fraction, could be a decimal. Depends on the problem. And the a can be any number that you want except one number, because if you let a be this number, it wipes the x out. What can't a be? Yeah, a can't be 0. And that's what this is saying in math words. This is saying that a and b are elements of the real numbers. A and b can be any real number, except a cannot be 0. Because to be a linear equation, you have to have an x in it. If you let a equal 0, 0 times x is 0, you just wiped it out. That's why a cannot be 0. Okay, so let's try solving a linear equation. There you go. Not a first linear equation that I would give someone in Algebra 1, but we're a little past that. So let's just jump right into this one and try it. Cesaro, what do I have to do? Well, which side do you think I have to do something with first? The left or the right?
Left.
The left. And can you tell me what I have to do on the left? Yep. And remember, this time it is a positive number, but if this was a negative 3 right here, you would be distributing negative 3. So you always distribute the sign to the left of the number. This technically has a plus 2 if you want to think of it that way. This is a positive 2 being distributed, and that's a positive 3. All right, so let's do that. So we get 4x minus 6. And Eli, what about when I distribute the 3 to the x plus 1?
You're going to get 3x plus 3.
3x plus 3. Okay, good. So we've distributed everything we can on the left. Declan, is there anything else I can do on the left?
You can combine like terms.
Yep, we can combine like terms. And Elva, can you tell me what I get when I combine like terms? So when you combine like terms on the left, what do you get?
So you get 7x
Yep.
minus 3.
Minus 3. Okay, so getting simpler. Chris, can you tell me what I got a couple options, but what could I do next?
You could subtract 5x from 7x.
Okay, so let's do that on both sides. And what else could I do at the same time?
You could subtract 2 from 3.
I could, but we want to put those numbers on the other side.
Or add 3 to 2.
Yeah, let's add 3 to both sides. So that gives me 2x equals 5. And now we can see that it does fit this pattern. Ax plus b equals 0. I could do this if I wanted to. Hey, I don't want to do that, but I could. So it is linear. And Anthony, what would my last step be to get x by itself?
Divide 2 on both sides.
Yep. Divide both sides by 2. And we get x equals 5 times. Okay. Any question on that? Yes?
If you had, like, say 6 over 3, would you simplify it or would you just leave it as that?
You would simplify it.
Can we go back to the top of the slide? Because I was writing things down. Like, yeah, that means you.
All right, so one type of equation that we can get that involves solving linear equations is absolute value. So an absolute value equation would look something like this. That's an absolute value equation. In order to solve this problem, we're going to split it up into 2. Split it into 2. But you can't split it until you isolate the absolute value. This is an example where the absolute value is already isolated. What I mean by isolated is you have an absolute value on one side and nothing else outside the bars on the same side. That absolute value is not isolated. What I would have to do first now is minus 1 from both sides. If I had something like 6 times the absolute value, that's not isolated either. I would divide both sides by 6 to move the 6 to the other side. So that's the first step. We want to make sure that it's isolated. And once it is, just like that, we can split it. Here's the directions on the 2 problems that we're going to split it into and solve. The first equation that you split this into, okay, so we'll usually draw 2 lines like this to split it. The first one is the same as the original. All you have to do is take out the bars. X plus 2 equals 3. That's going to be one of the equations you can solve, and you'll get an answer. Now, the second equation has one extra step. You still do what you did in the first equation, which was the original problem, take out the bars without the bars. But you have to change the number on the other side to a negative. So x plus 2 equals 3 would be your first equation. X plus 2 equals negative 3 would be your second equation. And you solve each one of those and get the answer. So you do have to solve 2 equations, but the equations are usually pretty simple. They're not as complicated as that last one with distributive property. In fact, they usually never have distributive property. So the first one, just take away the bars. The second one, take away the bars and negate or make the number on the other side a negative. I'm not actually going to solve that one, but we'll do another one like that. Remember, first step, make sure that you isolate the absolute value expression. In the problem I have for example 3, is the absolute value already isolated? Yeah. There's nothing else on the outside of the bars on the left side. So then we're ready to split it. What would be my first equation that I write down when I split this up? Matt?
2x plus 3 equals 5.
2x plus 3 equals 5. And my second one. Manny?
2x plus 3 equals -5.
Yep. That's it. So now you have two problems to solve, each one of them relatively short. Let's solve. 2x equals 2. X equals 1. There's your first answer. And we could check it. 2 times 1 is 2. 2 plus 3 is 5. And the absolute value of 5 is 5. So that one works fine. This one, subtract 3 from both sides, and we get 2x equals -8, which means x equals -4. And you could check -4, but that works as well. So that's called solving an absolute value equation. Any questions on that? All right, so before we look at quadratics, one more thing we're going to look at with linear. Then we'll finish with quadratics. So linear has one more type of problem, and that's called a mixture problem. And the idea in a mixture problem is you have to set up two equations, kind of like absolute value. You're going to set up two, and then you're going to solve. Now, let me show you. I just want to scroll down so you can see the kind of problem that we're going to do, and kind of see what they're going to be looking for. So the idea in a mixture problem, you don't write this yet, but the idea in a mixture problem is you have two different liquids to start with, and you're going to mix them together. You're going to mix a certain amount of the first solution with a certain amount of the second solution. And the goal is going to be, in this problem, to end up with 15 liters of solution when you're done. But they want the strength of the solution to be 12%. So you have to mix the right amount of 10 and the right amount of 25 to get 12%. So it's like concentrations. And you have to end up with 15 liters. Because they want you to end up with a certain amount, and they want that to have a certain concentration, that's why you need two equations. So the first equation, that one's pretty simple. You pick a variable that represents how much of the first solution you're going to use. You pick a variable that represents how much of the second solution you're going to use. And then when you add the two together, it should equal the total that they told you in the problem. So like A plus B equals, how many liters do they want? 30, 50, whatever they tell you. So the first equation has to do with the amount. The second equation has to do with the concentrations. And the second equation is going to be 3 pairs of things, all the same pattern. Concentration as a decimal, that's important. Concentration as a decimal times the first amount. The second one is concentration as a decimal times the second amount. And the third one, which I just ran out of space, is concentration, I'll put it like this, final concentration times final amount. So they're all concentration times amount. Concentration times amount plus the second concentration times the second amount equals the final concentration times the final amount. I just ran out of room to put that there. Again, that's as a decimal too. All right, so let's try an example with our problem. So we have two different solutions we're going to mix together. They will always tell you the percent of each solution. Like maybe it's like if you were doing something with like rubbing alcohol, you can look at the bottle. It says like it's a 90% solution or 70%. It tells you how strong it is. So we have a 10% solution and a 25% solution. And I called those two solutions A and B. And those will probably be the variables I end up using, A and B. You could call them X and Y if you wanted, but let's use A and B. We want to end up with a total of 15 liters, and we want the strength of the solution that we make to be 12%. You can always make a strength that's in the middle of the two. Like you could never end up with a strength of 40% because you're starting with 10 and 25. You don't have a strong enough one to make 40. So you can end up with something between the two by mixing them correctly. So what I need to do is I need to pick a variable that represents how much of solution, 10%, and how much I'm going to use of the 25%. I would just pick the variables that they already suggested. Let's let A be the number of liters that we use for the 10%, and B will be the number of liters we use of the 25%. Now, when we total up how much of A and B we mix together, what do we want the total to be when we're done making this mixture? Yeah? We want the total to be 15. That's our first equation. A plus B equals 15. That represents the total. Now, if that's all you knew, then you could say, well, could I mix 1 liter of A and 14 of B? Sure. That'll give you 15. I don't know if that'll give you 12%, but it would give you 15. But we also have to get 12%. That's the concentration. So now we need the second equation. So let's set up 3 sets of parentheses first. Concentration times amount, plus concentration times how much we use, the amount, equals the final concentration times the total amount of liquid. So let's start with our first concentration as a decimal. So this part is going to represent solution A, this part, solution B, and this part, the final solution. Okay, what's the concentration of solution A as a decimal? Max?
Is it a
0.1. Now, how much did we say, or are we going to represent how much of solution A we're going to use? What did we pick for that? Yeah, we picked A. 0.1A. Now, solution B. What's the concentration of solution B as a decimal? Yeah. 0.25. And how much, or how are we representing, bless you, how much of solution B?
B.
We're going to use B. Now the final solution. What's the final concentration that they want us to get as a decimal. Lucas.
Would it be 0.25 AB? I mean,
So the number we're going to fill in right here.
with that.
What's the concentration of our final solution they told us?
Would it be 2.5 or 0.5?
Well, 0.25 is the concentration of just solution B, but when we mix the two together, they told us they want a concentration of
Is it 15 liters? Or is it 12%?
which one? Which one's the concentration?
12%.
12%. So they want a concentration of 12%. And then what's the final amount that they wanted us to end up with? Yep.
Is that the 15 liters?
That's the 15 liters. So the right-hand side, we could just multiply those together and get that out of the way. 0.12 times 15. That's 1.8. Okay, so we got that out of the way. And let's write the left-hand side a little bit more compact. So that's 0.1a plus 0.25b. So there's your second equation. There's your first equation. Does anybody remember what you have to do with this top equation? And then fill it into the bottom equation. Because we have two variables. This is a system. Yep.
You have to isolate one of the variables and substitute the other one.
Yep. So we have to isolate one of the variables in the top one. Doesn't matter which one, A or B. Actually, which one do you want to isolate? B. It's about the same amount of work. And can you tell me what B would equal?
A equals would be negative B plus 15.
Well, you want to isolate B, right?
Yeah, so it'd be negative 2.5.
How would you get the B by itself here?
Subtract B.
No, you're isolating B. So you're leaving
isolating
B.
it. Okay.
Yeah.
Sorry. Subtract A.
Yep. And that gives you what on this side?
Negative A. Or no, B equals negative A plus 1.5.
You could write negative A plus 1.5, or you could just
15, sorry.
Or you could write 15 minus A. I'm just going to write 15 minus A. So that's B. Now take that and fill it in right there. So we're going to get rid of B in that bottom equation. 0.1A plus 0.25. I put parentheses because this is a distributive property with B. Replace the B with 15 minus A. Yeah.
Where'd you get the 1 times 8?
0.12 times 15.
Oh, okay.
Yep, we just did that out. So 15 minus A equals 1.8. Now, this is just like the linear equation I gave you with distributive property. Just solve for A. Except you only have to do distributive property once, not twice. So 0.1A plus 0.25 times 15. 0.25, it's 3.75. Minus 0.25A. Okay, what could I do next on the left? Yeah.
Combine like terms.
Yeah, I can combine like terms. 0.1 minus 0.25. 0.1 minus 0.25 gives me negative 0.15a. And how would I get this 3.75 on the other side? Yeah.
Do subtraction. it?
Yep, just subtract it. So 1.8 minus 3.75 gives me negative 1.95. And it's good that I ended up with a negative on both sides because A should be a positive number. And that negative is going to cancel that negative. And now just divide by 0.15. Let's see what we got. So 1.95 divided by 0.15 gives me 13. So in order to create the mixture that they want, I need to mix 13 liters of solution A. And how many liters of solution B? 2. Because I have to get a total of 15. So this would have to be 2. And that's how pretty much every mixture problem works. Same exact equations, just different percentages. That's all. So this reviewed something maybe you remembered, maybe you didn't. This is called substitution. So substitution is when you get a letter by itself and you plug it into the other equation. Okay, so that's substitution. All right, the last thing. So quadratics. Yes?
Can you go back to the one that-
So quadratics are like the next step up from linear. Okay, so quadratics, now we're dealing with equations that have an highest exponent of a 2. Just like linear, you can have a number here and a number here, and those two numbers can be anything you want. Positives, negatives, fractions, or decimals. But A cannot be a certain number. Anyone have an idea what number A can't be? Because if you let A equal this, then basically you wipe this out completely. Yeah?
0.
Yeah, A can't be 0. So A, B, and C can be any real number that you want, except A cannot be 0. Because if A is 0, now you have this. Well, now you've made it linear. That's not quadratic. So if the numbers work out nicely in a quadratic, one way that you can solve it is to factor. Factoring doesn't always work. It only works if the numbers are nice. Factoring is faster than the other way to do this if you're good at factoring. We'll talk about the other way to do it in a second, but let's try a factoring problem first. So sometimes what I do is I make a chart, and then it shows kind of the different cases you can have. So you have a middle term and you have a constant term. And there's really 4 different options that you could have. The case we have this time is a positive middle and a negative constant. When you're factoring, you're going to break this up into 2 sets of parentheses. Well, the symbols inside, when you have a positive here and a negative here, are a negative and a negative. Positive and a negative. That's important. Positive and a negative. Another case you could have would be a negative middle term and a positive constant. If that was the case, you're going to end up doing 2 negatives when you factor. You could also have positive and I already did that one. Let's do a positive and a positive. Positive middle, positive constant. Would be positive, positive. And what's the case I'm missing? Negative, negative. If you had a negative and a negative, it's basically just like the top one. It's a positive and a negative. So those are the 4 different cases that can come up when you're factoring. And this at least tells you how to get the right plus and minus signs. All right, so positive middle, negative constant, one of each. Now I need to put something times something so that I get 2x squared. Can somebody tell me 2 things I can multiply together to get 2x squared? Yeah.
2x and x.
Yep. 2x and x. Now I need 2 things that multiply together to give me 3. What can I multiply to get 3? Yep.
1 and 3.
1 and 3, and it does make a difference where I put them. I'll try a 1 and a 3. So 2x times x is 2x squared. 2x times negative 3 is that. 1 times x is that. What's negative 6 and a positive 1? Yeah? Negative 5. So I just have to make one small change here to fix this. What do I need to switch? Yeah?
The 1 and the 3, I think.
If we switch the 1 and the 3, we're going to mess up the number itself. We only have to fix the sum, yeah?
Or maybe the x and the 2x.
So whenever you get a sign that's the opposite of what you want, you switch your signs. Now you have 2x times 3. That's 6. Negative 1 times x is negative x. And 6 minus 1. There's my 5. Okay, so now we factor it. And the reason why we factor it is because it makes it easy to solve now. You have something times something equals 0. What's the only way you can multiply something times something and get 0 as the answer? What would have to happen? Yeah?
Oh, one of them has to be 0.
One of them, either this one has to equal 0, or that one has to equal 0. Well, if you let x equal 1/2, it would make this first one 0. So 1/2 is a solution. How about the second one? What could you plug in for x there? Yeah? Negative 3. And you need to write both. Okay. Any question on that? So that's factoring. In Algebra 1, I spent 2 or 3 days on it. We're not going to spend 2 or 3 days on just that. That's how you can factor. Now, sometimes you can't factor. And if you can't factor, then what we can use instead is the quadratic formula. And this is the last thing. Does anybody remember what the quadratic formula is? And I'll give you a hint. It has something to do with A, B, and C. Next?
Negative b plus or minus the square root of e squared minus 4 times a times c divided by 2. Okay.
Divided by 2a. Perfect. So that's the quadratic formula. The a, the b, and the c that Max just said come from the number in front of x squared, the number in front of x, and the constant. That's your a, your b, and your c. So if you had something like, let's say 3x squared equals 2x plus 6. Be very careful when you try to figure out what a, b, and c are there, because that's not its standard form. Standard form is when everything is on one side. So really, you would want to do this. So a would be -3, b is 2, and c is 6. Don't say a is +3. That doesn't work. So to use that formula, you want to write it like this. Doesn't matter if you put 0 on the left or 0 on the right. You can do it either way. Okay, but we'll finish up with solving a quadratic. Everybody have the formula first? Okay. All right, so there's our problem. 2x squared plus 2x equals 1. Jalen, first, is that written in standard form?
No.
No. What could we do? The easiest thing we could do to get 0 on one side.
Subtract both sides.
Yep. So 2x squared plus 2x minus 1. That's A. That's B. And that's your C. So let's fill it in to the quadratic formula and see what we get. So -b plus or minus, I don't know if I mentioned this, I think I wrote it up above, but this part under the square root has a name. It's called the discriminant. Well, I did write it. Okay, this part's called the discriminant. So -b plus or minus the square root of b squared minus 4 times a times c. What's a in this case? Yep. 2. And c is? Yep. -1. All divided by 4. Now, right away, when I look at the discriminant, I'm going to be subtracting a negative. So what happens when you subtract a negative number? Yeah? Turns into addition. So let's just handle that right now. So -2 plus or minus 4 times 2 is 8 times 1 is 8. 8 plus 4 gives me 12. And the square root of 12 can be simplified. Sometimes at this step you're done. Sometimes you have to simplify the square root. Anybody remember what the square root of 12 can be simplified as? Yep.
Would it be 3 times square root of 2?
Yep. So you can break 12 up into 4 times 3. 2 separate square roots. The square root of 4 is 2. The square root of 3, you can't do anything with it. And now, when we did that, look at these 3 numbers. It just happened to work out that every one of those numbers is divisible by what? 2. And that's our last step. Divide this by 2, you get 2. Divide that by 2, you get 1. Divide that by 2, you get 1. That doesn't always happen, usually doesn't happen, but this time it did. So the final answer is -1 plus or minus. You don't have to write 1 square root of 3. You can just write square root of 3. And then the denominator is 2. Yeah.
So in the equation up there, the one that's at the top of the actually no wait, not that one. Okay, you turned the negatives into a positive. Why was that?
I turn the negatives, oh, right here?
Yeah.
Because it was minus 4AC and C was a negative. So I was minusing a negative, which becomes a positive. It would have been 4 minus minus 8, which turns into 4 plus 8, which is 12.
Okay.
You got to change them to positives either now or later. So I chose to do it right away.
Yeah.
Okay, any question on that? All right. So the homework on page 89, that's a break-even point problem. So it just involves making a graph and finding an intersect. And that's it for page 89. Page 96 has a few linear problems to solve and a few quadratics. Let me just check number 58. Oh, yeah, that's okay. So we'll take a look at that tomorrow. And remember, if there's anything you need to make up, now you got a few minutes. Come check in with me, and we'll figure out a time to get that done.